In 1910, a German meteorologist was browsing a university library. He came across a scientific paper listing fossils of plants and animals found on opposite sides of the Atlantic Ocean, and he had a thought that would change science forever. What if the continents were once one? What if South America and Africa were joined like two pieces of a puzzle? What if all the land on Earth was once a single, massive supercontinent? On January 6, 1912, Wegener presented his theory to the German Geological Society. He called this supercontinent Pangea, from the Greek pan, meaning all, and Gaia, meaning Earth. All Earth, one landmass. And the scientific community laughed. They ridiculed him. They called his theory footloose and said it took considerable liberty with our globe. They hated that an outsider, a meteorologist, was meddling in their field. Wegener died on a polar expedition in Greenland in 1930. He never lived to see his theory accepted. He never knew he was right. He was right. And we know it now. But the story isn't over, because Pangea is coming back. Pangea was not always there. It took hundreds of millions of years to form. The assembly was well underway by the Devonian period, about 419 million to 359 million years ago. First, Laurentia, North America's core, joined with Baltica, Eastern Europe's core, to form Euramerica. Then Gondwana, the landmass that would become South America, India, Africa, Australia, and Antarctica, collided with it. By the middle of the early Permian, the Angaran Craton of Siberia joined the landmass. Pangea was complete. It stretched from the North Pole to the South Pole. 299 million years ago, the Earth had one continent. Pangea was C-shaped, with most of its mass stretching between Earth's northern and southern polar regions. Inside the curve of the sea was the Tethys Ocean, a warm tropical sea. The interior of Pangea was dry. Deserts dominated the tropics. The land was far from the ocean. Rain couldn't reach the center. It was a world of extremes. Pangea lasted for about 160 million years. To put that in perspective, the human species has existed for about 300,000 years. Pangea lasted more than 500 times longer than our entire species. And then, about 252 million years ago, Pangea may have helped cause the largest mass extinction in Earth's history, the Permian Triassic extinction, the Great Dying. 90% of all species disappeared. And after 160 million years, Pangea began to break apart. About 200 million years ago, during the early Jurassic, the supercontinent fragmented. It took another 100 million years for the modern continents to emerge. Alfred Wegener was born in 1880. He earned a PhD in astronomy. But his real passion was the Earth, its climate, its geology, its history. While browsing in the university library one day, he happened upon a scientific paper listing fossils of plants and animals on opposite sides of the Atlantic Ocean. He noticed the striking similarities between types of rock and fossils, especially fossilized plants. He noticed, as others had before him, the same jigsaw puzzle-like shapes of the continents. But unlike others, Wegener sought out many other lines of geologic and paleontologic evidence to support his theory. He pointed out that fossils of certain plants and animals, Glossopteris, Mesosaurus, Lystrosaurus, appeared on both sides of the Atlantic. While these organisms were alive, they couldn't have crossed the ocean. The only explanation: the continents were once connected. He also showed that glacial scars in Africa matched glaciers in South America. Coal deposits in cold regions suggested those areas once had tropical climates. The climate belts of eastern South America matched the southwestern coast of Africa. The evidence was there. The world wasn't ready. In 1915, Wegener published his book, The Origin of Continents and Oceans. It laid out the first comprehensive theory of continental drift. The backlash was vicious. Geologists who resented this outsider's revolutionary ideas attacked him mercilessly. The American Association of Petroleum Geologists organized a special symposium to oppose his theory. Wegener's hypothesis is of the footloose type, said one critic, in that it takes considerable liberty with our globe and is less bound by restrictions or tied down by ugly, awkward facts than most of its rival theories. The geologists had a point. Wegener couldn't explain how the continents moved. He thought it might be the centrifugal force of Earth's rotation or the gravitational pull of the moon. He was wrong about the mechanism. In 1930, Wegener died on a meteorological expedition to Greenland. He was 50 years old. He never lived to see his theory vindicated. He died believing he was right. He was, but it took 50 years for the world to accept it. In 1947, researchers started using sonar to map the ocean floor. They discovered something unexpected: mountains in the middle of the Atlantic. The Mid-Atlantic Ridge. Marie Thorpe, a cartographer at Columbia University, created the first detailed map of the ocean floor. She revealed the Mid-Atlantic Ridge, a basaltic mountain range spanning the length of the Atlantic. In 1962, Harry Hess proposed the seafloor spreading hypothesis. The mid-ocean ridges were like tectonic plate factories. New oceanic plate was issuing from these long volcanic ridges. Scientists mapped the magnetic field of the seafloor. They found strange magnetic anomalies, a striped pattern of symmetrical rows on both sides of mid-oceanic ridges. The magnetic poles within each stripe reversed in alternating rows. The seafloor was spreading. The continents were moving. Wegener was right. By the late 1960s, plate tectonics was the scientific consensus. Earth's outer shell consists of large rigid plates that move apart at oceanic ridges, come together at subduction zones, or slip past one another along fault lines. Wegener's theory was vindicated. 3 decades after his death, the plates move at roughly the speed fingernails grow. A few centimeters a year. Over millions of years, that's enough to open oceans, trigger earthquakes, and lift mountain ranges. Pangea was not the first supercontinent. It was part of a cycle. Supercontinents tend to come together and break apart every 400 million to 600 million years. Rodinia formed about 1.1 billion years ago. It was the first supercontinent we know of. Pannotia formed about 600 million years ago. It broke apart to form Gondwana and other land masses. Pangea formed about 299 million years ago. It was the most recent and most famous supercontinent. 400 to 600 million years, the rhythm of the Earth. We are living in the middle of this cycle. The continents are moving. The Atlantic is widening. The Pacific is closing. And in about 250 million years, the cycle will complete. Pangea is coming back. Geologists have proposed 4 possible futures: Novopangea, Pangea Ultima, Aurica, and Amasia. Each one depends on how the plates move in the next 250 million years. In Novopangea, the Pacific keeps closing while the Atlantic keeps opening. The Americas drift farther from Europe and Africa. Antarctica shifts north. The continents eventually collide on the opposite side of the world. In Amasia, most of the land gathers around the North Pole, a frozen supercontinent at the top of the world. In Aurica, both the Atlantic and Pacific close. A new ocean basin opens across Asia, a supercontinent in the tropics. The most likely outcome is Pangea Ultima, also called Pangea Proxima, first described in 2003 by paleogeographer Christopher Scotisi. The Americas, Africa, and Eurasia collide along the equator. Pangea Ultima, the supercontinent that will form in 250 million years. In Pangea Ultima, Spain is in the far north, at the coolest edge of the supercontinent. The interior is a vast desert. The coasts are humid and hot. Scientists using supercomputer climate models have simulated the climate of Pangea Ultima. It will be unbearable for mammals, a triple whammy of extreme heat. Dr. Alexander Farnsworth of the University of Bristol calls it a triple whammy. Three factors combine to create a world of extreme heat. First, the continentality effect. The center of a supercontinent is far from the ocean. Oceans regulate temperature. Without them, the land becomes a desert. Temperatures soar. Second, a brighter sun. Over millions of years, the sun will emit more energy. It will gradually warm the Earth. In 250 million years, it will be about 2.5% brighter than today. Third, increased carbon dioxide. Volcanic activity from tectonic shifts will release massive amounts of CO2. Levels could rise from today's 400 parts per million to over 600 ppm. The combination would create temperatures between 40 degrees and 50 degrees across most of the supercontinent. That's 104 degrees to 122 degrees, with high humidity. A lethal combination. Mammals cool themselves by sweating. But when humidity is high, sweat doesn't evaporate. The body can't cool down. Overheating causes death. This is the heat stress that would kill most mammals. The study projects that only 8% to 16% of land would be suitable for mammals. The rest would be too hot, too dry, too deadly. A mass extinction caused by a supercontinent. The formation of Pangea Ultima would involve enormous volcanic activity. The tectonic plates colliding and compressing would trigger eruptions. More eruptions mean more CO2. More CO2 means more heat. The last time Earth was this hot was during the Permian-Triassic era, about 260 million years ago. That's when the Great Dying happened. 90% of species went extinct. The cycle of supercontinents is a cycle of death. When Pangea existed, dinosaurs walked from one end of the supercontinent to the other. There were no oceans to stop them. The animals could roam freely across the entire landmass. The herbivorous dinosaur Plateosaurus appeared in southern Pangea, Argentina, Brazil, about 230 million years ago. It took 15 million years to show up in the north, Germany, Greenland. 15 million years to walk across the land. The delay wasn't geography, it was climate. Prior to the dispersal, CO2 levels were about 4,000 parts per million, 10 times higher than today. Deserts encircled the tropics. Those deserts were a climatic barrier that dinosaurs couldn't cross. Then, a dip in CO2 reduced the aridity of the planet's tropical desert belts. The barrier lifted. The dinosaurs could cross. They moved north. CO2 shaped the dinosaur world. It will shape ours. The Great Dying, 252 million years ago, was also linked to Pangea. The supercontinent caused shallow water habitats to decline. Cold polar waters couldn't reach the tropics. Oxygen levels dropped. 95% of marine species died. When Pangea broke apart, the opposite happened. More shallow water habitat emerged. Warm and cold ocean waters mixed. New habitats were created. Biodiversity increased. Pangea creates death. Its breakup creates life. The cycle of supercontinents spans 400 to 600 million years. That's longer than the age of complex life on land. Pangea existed from about 299 million years ago to about 200 million years ago. It lasted 100 million years in its fully assembled state. 160 million years. Pangea, 300,000 years. Humans. Pangea lasted more than 500 times longer than our entire species. Tectonic plates move at 1 to 15 centimeters per year. That's the speed your fingernails grow. Over 250 million years, that's enough to move continents thousands of kilometers. In 250 million years, Pangea Ultima will form. By then, the sun will be 2.5% brighter. CO2 levels could exceed 600 ppm. Temperatures on Pangea Ultima could reach 40 to 50 degrees Celsius. That's hotter than today's hottest deserts, with humidity that makes it impossible for mammals to cool down. Only 8% to 16% of Pangea Ultima would be habitable for mammals. The rest would be a death zone. The last time temperatures were this high, 90% of all species went extinct. These numbers are not speculation, they are physics. Earth's distant future is a supercontinent, a greenhouse, and a mass extinction, and there's nothing we can do to stop it. We are living on a planet that has been through this cycle before, and it will go through it again. We are not the first. We will not be the last. Wegener saw the truth. He saw the jigsaw puzzle. He saw the fossils. He saw the evidence, and he was ridiculed for it. He died before he could be vindicated. He died believing he was right, but he never knew that the world would eventually agree. The truth is patient. It waits for us to catch up. The Earth has a rhythm, 400 to 600 million years. Supercontinent, breakup. Supercontinent, breakup. It's the heartbeat of our planet. We are living in the middle of a cycle that began 500 million years ago. 250 million years from now, Pangea Ultima will form. The Earth will be a single continent again. The oceans will be a single ocean again. Mammals may not survive it. Something else will. Dr. Farnsworth said, "What comes after is anyone's guess. The dominant species could be something completely new. We are not the end, we are just a chapter. Earth is our only home, and it has a rhythm, a cycle, a fate. We are standing on the shoulders of Wegener, looking toward the future. The map of Earth has changed. It is changing. It will change again. The universe is watching. Are we paying attention?" In 1910, a meteorologist saw a jigsaw puzzle in a library. He spent the rest of his life trying to prove that the pieces fit. He was right. It took 50 years to prove it. Wegener was vindicated, but not in his lifetime. The theory of plate tectonics is now the foundation of Earth science, and it all started with one man's vision. Supercontinents come together. Supercontinents break apart. It has happened before. It will happen again. Pangea was real, and Pangea Ultima is coming. In 250 million years, a new supercontinent will form. It will be a world of extreme heat, a world of mass extinction, a world where mammals may not survive. The Earth is a living planet, and it has a rhythm. Wegener died on the ice in Greenland. He was trying to understand the Earth. He was trying to understand the climate. He was a pioneer. He died before his time, but his time came. The acceptance of plate tectonics in the 1960s was a revolution. It changed how we understand earthquakes, volcanoes, and the history of the Earth. Wegener's vision became the foundation of modern Earth science. The formation of Pangea Ultima is a warning. The cycle is natural, the destruction is natural, but it's also inevitable. The Earth doesn't care about us. It follows the laws of physics. We are fragile. Our existence is fragile. Our civilization is a flicker in the deep time of the Earth. We are a footnote in the history of a planet that has been through this before. The planet will continue, with or without us. The universe is watching. Are we paying attention? What Wegener saw in 1910 was just the beginning. What we see now is the full story, the cycle, the rhythm, the future. Pangea exists in the past. Pangea Ultima exists in the future. The Earth's distant future is a supercontinent of deadly heat. The cycle will complete, and the Earth will be transformed. We are the children of Wegener, and we are the witnesses of the cycle. The cycle continues, the Earth will continue, and the universe will continue. We are a small part of something vast, and we are paying attention. The Earth is beautiful. The Earth is violent. The Earth is indifferent, and it is our only home. The universe is watching. Are we paying attention?